everyone, and welcome back to Mr. Anderson's Algebra 1 lessons. You're visiting me out of my home today, and I will be making a tutorial on radicals. And I hope you can see this okay, but I've set up a couple examples for us to practice today. And I want to take a look at some basic radicals as well as simplifying and combining like terms. Just some things like that. So forgive me if my camera's out of focus. It is kind of old and it likes to move around. So let's just get into it and do our thing. So first off, we got the square root of 72. And one thing that I always tell my students is that when you are looking at something like this, you're asking yourself this question: what number times itself is equal to 72? That's what the square root is asking. So when I always do these, I always talk to my students also about finding the factors of 72 in order for them to figure out what to look for when you're finding the square root. So when I'm looking at 72, I know that if I multiply, if I just make a factor tree, often I tell my students, hey, what numbers multiply to 72? And you know, they can take out their calculators or whatever they want. But I do know a couple numbers. You got 2 and 36. If you use a calculator, you can divide by 4, you'll get 18. And if you do, let's see, 72 and 6, you got 6 and 12. And I think that's going to be about it for our stuff. Man, that is just bad. Oh my goodness, I am sorry. Hopefully that'll stay right there. So I got my factors here, and I'm going to pick the one that gives me a perfect square. Now I see a couple perfect squares, but I'm looking for the biggest perfect square, and the biggest perfect square I see is 36. So I'm going to make my little factor tree and factor this out into the square root of 36 times the square root of 2. And I know that the square root of 36 is 6. And the square root of 2 stays the same. So square root of 72 is 6 root 2. That's my answer. Now this one's a little bit bigger. So with this guy, you might need to bring out a calculator or something to help you find that list of perfect squares. So I got 252, and I'm always going to start with 2 because that is a big number that we can factor it out. 126. I guess we could always do 4. 63. That looks interesting. And then let's see. Let's try 6. 6 works. Okay. Let's try 7. 7 works. 7 and 36. I'm gonna stop there because 36 seems like a pretty big perfect square, and we already figured out that the square root of 36 is 6 from this guy. So I'm just going to split that up like this. Square root of 36 times the square root of 7. And I know that that's going to give me 6 square root 7. Square root of 7 doesn't have any perfect squares or any other factors for that matter, because 7 is a prime number. So it is not going to have anything to reduce to or simplify into. So I'm just going to leave it. So this one is my answer. Now moving to this guy, this is going to be a bigger one. So we're going to have to really take this one into consideration. I know that 45 has a couple factors. We got 9 and 5 are a factor. Pencil ran out of lead. 9 and 5. And And isn't that really the only factors? 1 in 45. But something else that's special about this guy is that we have this b right here that we need to take care of. And that's kind of a problem because what do you do with that? So I think what we should focus on is, remembering that we have to ask ourselves this question: what number multiplied by itself gives me this? And that's kind of, well, what do you do there, Mr. Anderson? So just sit tight, let's figure this out. I know that we can split this into two terms. So I know that if I got an idea, just bear with me. There's a property called the commutative property that if you multiply this stuff times this stuff, it always has to go back to this stuff. I don't know if that's 100% correct, but hear me out. So the premise is if I multiply this term by this term, I'm going to get this term. And if that doesn't work, then you're doing something wrong. So just bear with me. If I square root something, it's going to take the square away. And if I square root this 9, that's a perfect square. It's going to give me a 3. So that's going to take this away, and I'm going to have 3b times the square root of 5b. Now, I can't get anything else to simplify into this, but if I multiply all this out, I will get that back. And so this is going to actually be my answer for this term. So there you have it. Let's move forward to the last piece of this video today, where we combine like terms here. Now this one's pretty straightforward. We can only combine terms together that have the same base or the same term. And so if these two terms were any other numbers inside the square roots, we could not combine them together. So since they're the same, I can bring them together. So that would mean that my base is going to be the square root of 10, but now I need to figure out what that is. So negative 4 take away 5, it's going to give me negative 9. And that's my answer, simplified. The square root of 10 I cannot do because it can't simplify anything else. It's not a prime number, but it has no factors that simplify down if you take their square roots. So this is actually our answer. Let's take a look at this guy. It's a little bit bigger. I bet it's going to take a while to do because none of these terms have the same base. So what I'm going to probably do is I'm going to probably see, I can't do anything here, but I'm going to probably simplify this guy first because maybe it has some other terms I can combine together. And so what I'm going to do there is I'm going to just take a look at it and see what we got here. So we got square root of 20, that's going to be the square root of 4 times the square root of 5. Hey, look, square roots of 5. So maybe that's going to be something we can do together. So that gives me 2 square root 5. Subtract square root 2. And negative 3 square root 5. Okay. So it looks like we got nothing else to combine with the square root of 2, but I can bring this 2 square root of 5 and this 3 square root of 5 together. And that's negative 3 square root of 5. Let's just rearrange this. That looks better. So now I can combine like terms. And I get negative 5 square root 5. And that's my answer. I can't really do anything other than that. And that's how I would simplify that radical term. And again, this has been Mr. Anderson's Algebra 1 Lessons. dealing with radicals. I hope you enjoy, and happy studying, and I wish you all the best.